The part 2 of chapter 3 is to learn a tool called the kmap or Karnaugh map. As you have a Boolean function simple, then it causes less hardware, so the simpler the better. So that's what we know that. But using the Boolean function identities like inverse identity, commutative, distributive law, and the like, and then trying to simplify the function is time consuming, also error prone. And sometimes we don't know whether we have reached the most optimum expression after simplification or not. So we have an easy and systematic method for reducing Boolean expressions. 1953, Maurice Karnoff developed such a tool when we were at the Bell Labs. So this is graphical representation. It's known as a Karnoff map or K-map in his honor. So here is a few terminology to understand the K-map. Basically, K-map is a matrix. It's two-dimensional matrix. So it's a tabular data consisting rows and columns. And that table represent output values of a Boolean function. So we have studied the truth table. So K-map is just a two-dimensional representation of a truth table. Truth table is one-dimensional. K-map is a two-dimensional. So here, another terminology is called the min terms. Min term in a Boolean function is a product. A product here means ANDed together. Product term that contains all of the functions variables exactly once, either complemented or not complemented form. So if you have a function which is two variable x and y, then min term could be xy, since all of the variables appear either complemented or uncomplemented. Another min term of function with the two variables x not y, or x y not, or x not y not. So with the two variables, a function has four min terms. So here is the representation of that. Using two Boolean function, we have two variables. So we have four min terms, all complemented. One of the two is complemented, none is complemented. And there, this min term represents when x is 0 or y is 0, this becomes a 1 or true, and so on. So min term is very similar to the truth table representation. Three variable function, we will have 8 min terms listed here, there, and then corresponding values are listed on next column. So K-map for two variable is change the truth table into a two-dimensional matrix. Basically, that's the one. So suppose you have a Boolean function which is xy, then truth table says xy is 1 only if x and y both are 1s, otherwise it's all zeros. So this is truth table representation. And then Karnough map, K-map is so make it two-dimensional, since we have two variables, one for each row and column. And then when you put this one, the variable x appears first, though, so it should be heading for row, and then heading for column. Y becomes for that. So this row is when x is 0, and this row is when x is 1, and this column is when x is 0, and this column is when y is 1, and the like. Then exact same truth table you can represent in two-dimensional matrix, and this is called a K-map. So using K-map, now we find the exact expression of the function. So when a given function x or y, then truth table is like this. So you have a 0 and then the rest is 1. But we write it as a K-map. This is the function. Then out of this truth table, we can list the sum of products form. So the first one is x not y, and then this one is x y not, and this is one is x y. So actually function is represented by this one. Also from kmap we get exactly the same idea. So this min term is when x is 1, y is 0. So this min term means x, y. And this min term means x is 0, y is 1. So x is 0, y is 1. So x not. This one means oh, this one is x and y is at 0, so y not, and this one is x and both y both are 1. So function is represented by min terms like that. So either truth table or from kmap you can get the same information. But using kmap, now you can simplify the Boolean functions as follows. What you do is given kmap, the function was x, y, x or y was the function, then we have a kmap representing the function. But originally, if we didn't do simplification yet, the function is represented by x not y plus x y not plus xy. So each min term represent that information. Then out of this, how do we simplify is a group neighboring cells together if values are 1. And then the grouping should be 2 or 4 cells together. Since we have all four cells in this table, if all of those are 1, then we can group as 1. Otherwise, just group by 2. And then the grouping should be either vertically or horizontally. You cannot do diagonally. And then each group we find the simplification. So this red one is actually in Boolean expression. The first min term is x and y not, and then this one is x y. But if we utilize a Boolean algebra identity, then we can use a distributive law x y not and y, and this is a inverse, so which is 1, and then using identity which becomes x. In green part, this one is x not y, since x is 0, and this one is also xy. Also you use a distributive law, factor y out, then from inverse we have a 1, and from identity we have y. So overall the function is a x plus y. So that's how we reduce or simplify using Boolean algebra identities. However, from this kmap you can get those simplified expression directly, such that within the group, so two adjacent cells we can group together horizontally, then expression for this group is we can find such that within this group we find that x value is 1 unchanged across the cells. X is always 1, but horizontally we see that the first one y is 0, second one y is 1. So if the variable value changes within the group, like y changes group across, but x does not change, then the representation of this group is the variable of which value do not change. So this group is only x. Similarly, for green one, in this group we find that y value does not change. However, x value changes 0 and 1. So this group is only y. The variable of which value changes are eliminated. So the function simplify the result of this function is simply x plus y. That's it. So why do we eliminate the variable with the changing values based on this one, x not plus x, out of inverse? So out of inverse, so this one is same as x not plus x in red one. So we from Boolean algebra identity, this inverse is 1. So this disappears. So this way x changes, and this way y changes. Y plus y not is 1, and the like. So when you derive simplify the expression from a kmap in the group, just keep the variable of which value do not change. But if the value of the variable changes, just take it out, and then that's simplify the expression of a corresponding group.